Okay, guys, so let's continue with more functional groups. Yes, there are more. There are many more that you have to know and understand. And so the next functional group that we're going to do is a ketone. And so a ketone, we're going to change it into ONE. And so let's look at a ketone. So a ketone, what you're going to look for is, again, a C double bond O, but this time the C that is attached to double bond O is actually in the middle of a carbon chain, so it's not at the end. So it's kind of like an aldehyde, except it's in the middle. So aldehydes are at the end of a chain, ketones are in somewhere not at the end, at least two carbon in from the outside of the chain. And so, for example, so our first ketone that's even possible has to have 3 carbons, so that we can have the carbon in the middle of the chain. So there is our first ketone that is possible. And then fill out with your hydrogens. Remember, this carbon here can't have another hydrogen down here because that would give it 5 carbons. Or, I'm sorry, 5 bonds, 10 electrons in the valence shell. That won't work. And so 3 carbons is propane. But since we are a ketone, we're going to drop the E and we're going to add ONE. So it's now propanone. Propanone. That's how we're going to name that. And so we could do another example of a ketone. We'll make this one longer. And let's make the ketone right there in this case. And now we're going to have to tell us where the ketone is. Okay. So where is our functional group? It is on, just like everything else, we're going to number our carbons, and it is on carbon number 2. And so that's where our ketone is. And so you could say, let's just see, 1, 2, 3, 4, 5 carbons. So that's a pentanone. It's a pentanone, or drop the E, add the ONE, pentanone. And the one is on carbon 2, so we could say this is 2-pentanone. Is what we can say. If it's real simple, we don't have other functional groups, just put the 2 in front, 2-pentanone. Otherwise, if we have other things on here as well, then we might want to go ahead and throw that 2 into the name, and then we would say it's pentane 2-one, just like we've been doing some of the other examples as well. Okay? And so those are ketones. So ketones have a C double bonded O somewhere in the chain, in the middle of the chain, not on the outside of the chain. So those are ketones. All right, next one that we're going to do are carboxylic acids. Carboxylic acids. And so when we look for a carboxylic acid, we're kind of back to an aldehyde, except we've made a modification. So an aldehyde would have a C double bond O to an H. Now we're going to replace that H with an OH. And so that is and that's going to be attached to some other carbon. So carboxylic acids are also terminal. They're at the end of chains. So at the end of chains. That's what carboxylic acids are. So that is effectively what we're looking for to identify it as a carboxylic acid. And so let's just do a 2-chain carboxylic acid. So CC, double bond O, OH, and it needs to be filled out with hydrogens. And so that would be ethane, would be your basic name. But we're going to change it because it's not ethane. We've added a functional group. So for carboxylic acids, we're going to drop the E and we're going to add oic acid. That's what we're going to do. So this is now going to be ethane, drop the E, add oic, and acid. Ethanoic acid would be this structure. We'll try another one. Let's go up to, let's go for 5, and we'll do the carboxylic acid on this end in this case. And that's perfectly okay. We can do it on the other end. We don't have to be on the right side of our chain. And so this has 5 carbons. Remember, now the C that's part of the carboxylic acid counts in your chain. It's included in your chain, so make sure you do that. So 5 carbons would be pentane. However, we're going to drop that E. Take that E that would be here, drop it off, add oic acid. So pentanoic acid would be the name of that. Let me back up for just a second because we need to do condensed formulas. What would the condensed formula look like? So let me change color so it stands out a little bit. This would be CH3, CO, CH3. That's what we're going to look like. So if you see a CO in the middle somewhere, well, that CO, that's that double bond O coming up with it bonded to the C and the C and then double bond O. So in this case, we would draw that out. We'd say that's CH3, CO, CH2, CH2, CH3 would be what that would look like. Let's go do our carboxylic acids as well. And so I've seen this a couple of ways. I think what I usually see more often than not, we'll have a CH3, and then this C double bond O, OH will be written as COOH. That's how that's going to be written, COOH. And so in this case, and even if it's written this way, we're probably going to write it with the COOH on the right side in the condensed formula. So we'll do this backwards. So this will be our CH3, and then this will be our next one, CH2, 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 COOH. That's how we would write that out for pentanoic acid. Okay? So those are your carboxylic acids. We have two more that we're going to do. So amines are next. Amines, that's an M right there, amines. And amines are going to have an NH2 group attached to the carbon. So now we're getting out of carbons. We're adding a nitrogen instead. So that's going to be an amine. And so, for example, let's do this one. So we'll do the ethane. So again, these are H's here. But we're going to take one of those H's off and we're going to replace it with an NH2 group. And so that's now an amine. And so, again, normally this would be ethane. And there's a couple of ways to name these. It seems like there's always a couple of ways to name them. One way that you would see these named is you would use this as a alkyl group. Okay, and so that's a 2-carbon group, so that would be ethyl. And then this is an amine, so this would be ethyl amine. That would be one way to name it. The other way that you could name it is you could put the amine in the front, and it would be amino, and then whatever this would be in the normal name, which would be ethane, so aminoethane. That would be another possible way to see that. And so I want to show you all possible ways that you may see this. And so let's do another one. So there's that. We might see this as propylamine, or you might see this as 1-amino propane, and you should have a 1 up here too, 1-propylamine, because the amine's on the first carbon. Okay, 1-propylamine or 1-amino propane. If the that's not propane, propane. Let me spell that correctly. Propane. If the amino group was on the second carbon, then that would be 2-propylamine or 2-amino propane. So either of those methods would be correct. All right, and then I think we'll probably do one more. We may not go beyond that at this point in time. But there are others that we'll do. But for right now, I think we're going to stop with the esters. And these are going to probably be the most complicated ones that you are going to see. And so an ester is a little bit different kind of a creature, if you will. An ester is made from the combination of a carboxylic acid. So you combine a carboxylic acid and an alcohol. And that's how we get an ester. And so let me show you a simple one. So let's take an alcohol we'll take a simple alcohol. So this would be methanol. And let's take a carboxylic acid. I'm going to flip it around so that the OH is over on this side with the O. Okay, and so these would be H's here. And so this would be a 2-carbon carboxylic acid, which would be ethane, and we're going to drop the E and add oic acid, so ethanoic acid. Okay, and then what happens to make a carboxylic acid is that we have a reaction that occurs, and an H and an OH are going to come off and form water, and then this O is going to bond to that C. Okay, and so what we'll get is we're going to get a C O bonded to a C double bonded O with the CHs. Okay, and so hopefully you can visualize that. This right here came from the methanol, and then this part is the carboxylic acid. Okay, and the way that you name these is you name the alcohol portion first as a alkyl group effectively. So that would be methyl. And then the carboxylic acid, in this case was ethanoic, the oic becomes O8. And so this would be ethanoate. So this is methyl ethanoate. That's what the ester is when you combine this right here. When you combine the methanol and the carboxylic acid to get the ester, it's methyl ethanoate. So let's do one more example of that. So let's say that we had a carboxylic acid, or let's say we had an ester, and normally they're going to be written this way. So we'll do this one, 3 carbons long there, and we'll do 2 carbons long there. Okay, so here's what you got to figure out with writing out, need some H's there, with writing out the names of esters. This is probably one of the more complicated ones that we're going to have to do is esters. Not this particular example, but just esters in general. So right here, that's one of them. And then this is the other one. And actually, we need another bond on that C there. Okay, and so this had the OH. This was the alcohol, and then this was the OH there. And so we took that H, those 2 H's and that O, pulled them out, made water, and then allowed the bonds to form across. And so this side here was the carboxylic acid, and this side here was the alcohol. Okay, and remember the alcohol name is basically named as an alkyl. Okay, and so a 2-carbon alcohol would be ethyl. Okay, and so this is ethyl, and you always write the alcohol portion first. Okay, in the name it's ethyl. And the carboxylic acid name, this was a 3-carbon carboxylic acid, so that's it was propanoic acid, propanoic, but the oic becomes O8, so it's propanoate. So this is ethyl propanoate. So there's that, and that name came from there. So ethyl propanoate is what we would call that. And so this is our, our ester linkage, if you will. That's what makes an ester. If you want to write the condensed formula here, so we have a CH3, and then here we have a CH2, and then we have a COOC. That's our ester right there, a COOC, H2, and then a CH3. Okay? That's kind of sloppy there at the end, so let me fix that up. So CH2 and then CH3. So this is what an ester is going to look like in the condensed formula. Again, we're going to have plenty of practice on writing these in class. I just want to get you the introduction to them so that you won't be completely lost. Okay.